Okay, welcome everybody. I'm going to do an example here. It should cover everything from chapter 6. So if you're still unsure of how to do some of the questions involving z-scores and percentiles, just follow along here. Okay, so let's just get right into it. So suppose a normal model describes the fuel efficiency of cars currently registered in your state. The mean is 24 miles per gallon with a standard deviation of 6 miles per gallon. So the first thing I want to bring your attention to is the fact that they tell us it's a normal model, which means it's symmetrical. Our data is symmetrically distributed, with no it's not skewed, and we can use the normal model. Okay, so I have my mean as 24 miles per gallon, and if you're just still unsure with what the here, it's obviously better if if the car you drive can get more miles per gallon. That means it's more fuel efficient. So the more miles per gallon, the better it is here. Okay, just sort of in terms of thinking if a positive z-score is good or bad. In this case, the better the z-score, the better the more fuel efficient your car is. Okay, so let me put that 24 right here. So standard deviation of 6, which means over here we're going to have 30, 36, 40, and then down here it's going to be 18, 12, and then 6. So down here near 6 and 12, you're looking at some big trucks that use up a lot of gas and don't get quite as many miles. So let's look at our first sort of standard deviation is right here and right here. So from our 68% of the data, in other words, 68% of all vehicles fall between 18 and 30 miles per gallon. So that would be 68% in there, and then from 2 standard deviations, okay, this would be 95% of the data. Let's fit it in here. 95% of the data. And then finally 3 standard deviations, which is just the tails here, you would get 99.7. So from here to here, 3 standard deviations, you would get 99.7% of all cars are between 6 miles per gallon and. So to answer this question fully, you would say, according to the normal model, we would expect 68% of the vehicles to be to have between 18 and 30 miles per gallon of gas consumption. We would and 95% of vehicles would have gas consumption between 12 and 36 miles per gallon, and finally 99.7 of all vehicles would have a gas consumption for between 6 and 40 miles per gallon. So anything really outside of 6 and 40 would be a very special, unique value. Okay, let's move on to the next one. Okay, so what percent of all cars get less than 15 miles per gallon? Okay, so let's first of all let me just label this again. So again, 24. So again, always start with a diagram here. So 24 is my mean value, and I'm looking to find out where 15 is. So this would be 18, this would be 12. So my value that I'm looking for would be somewhere here, 15 miles per gallon, and this is miles per gallon here. And again, so I want to label that. So what are we looking at? So what percent of all cars get less than 15 miles per gallon? So I'm looking for the area over here. Okay. So again, so first thing we need to do is turn this 15 into a z-score and then get the percent. Okay, so let's calculate the z-score first. So the z-score equals our value, y, minus the mean, the mu, okay, divided by the standard deviation. Okay, so we have 15 minus 24 over 6. Our standard deviation was 6. So you'll see you get a negative value here, and that's because 15 is less than the mean. Okay, so let me get my calculator here. Okay, so we have 15 minus 24 divided by 6. Oops, divided by, so negative 9 divided by 6. So I get negative 1.5 as my z-score. Whoa, what happened there? Okay. So the z-score here, that's equivalent to 15 miles per gallon, is a negative 1.5. Okay, now once I get, let me shrink this over here. So once I get my z-score, I can now on my calculator convert that to a percent. So let's so again, so I need to go from negative infinity here, from 0, okay, all the way to 15. So what area is this over here? So you go second function, variables, normal CDF, and my calculator automatically puts the lower bound at a really low number. My upper bound is negative 1.5. And again, if your calculator doesn't show this, you might have to put in negative 99, comma, negative 1.5, comma, 0, comma, 1, and then hit enter. Okay, so I get 6.68% here. So 6.68%. So according to the normal model, we expect 6.68% of all vehicles to get less than 15 miles per gallon. Okay, that's how you would answer that question in the context of the problem to get full marks here. Okay, let's move on. Okay, so this one, okay, we have to do an interval here. So what percent of all cars get between 20 and 30 miles per gallon? I keep forgetting what my mean is. Okay, my mean is 24. All right, let me fill that out again. 24. Oh, I'm getting this thing here. Okay, stay there. Thank you. All right, 24. And then I'm looking for between 20. So that's going to be somewhere here. And 30 is going to be, well, 30 is actually right at the first standard deviation. So that's 30. And that is 20. So I'm, again, percent corresponds to the area under the curve. And in this case, that is the area I'm looking for. So again, first thing, I need to convert both of these scores to z-scores. Z-scores will be down here. So let's get let's do the first one. So 20 minus 24. Why is that happening? 20 minus 24 divided by standard deviation. So that'll give us the z-score, and that's negative 4 over negative 4 divided by 6. And that should be what is that? Negative 666, and then you can do 4 decimal places here. Okay, so that's the z-score there, negative 0.666 6, 7, and 3. Well, 3 is easy. Excuse me. 3 is easy because 3 is right. Sorry, 30 is easy. My pens keep disappearing here. That's annoying. That should be 30. 30 is right at the first standard deviation. So this z-score for 30 is equal to 1. Okay, that's 1 standard deviation. So I'm trying to figure out the percent between these two z-scores. So on my calculator, second function, normal CDF, and instead of doing 0 or negative 99 here, I'm going to put in my first left boundary, negative 0.6667, all the way to positive 1, and I get 58.88. So 58, what a pain, 58.88. I'm not sure why that's happening, percent. So the full answer here would be, again, according to the normal model, we expect 58.88% of all vehicles to have to get between 20 and 30 miles per gallon. All right, let's move on. Okay, what percent of cars get more than 40 miles per gallon? Okay, so let me do my let me move this down a little bit more. Okay, so where's 40? So if that's, I'm not sure why that's happening now. Okay, that's 30. That's 36. And so 40 will be somewhere, let's give it a different color here. So there's 40. Oh, what a pain. Miles per gallon here, okay? Now, so the key thing here is more than 40, so the area we're looking for is tiny, right? It's going to be the far right tail here. So our left boundary is going to be 40, and the right boundary is going to be, positive infinity. But again, I need to get a z-score for 40. So the z-score for 40, let me do a little black here. Z-score for 40 minus 24 divided by 6 here, and that is, what is that, 16 divided by 6, and let me just do that one. 16 divided by 6 will be 2.66 again, or 667. All right, so that's my z-score, and let me see if I can fix this a little bit. Okay, that's fine. Okay, so second function, variables, normal CDF, 2.666. You can just keep hitting the 6 here. The more decimal places, the better while you're doing your calculations. And then the upper boundaries, you can just hit 99. Doesn't matter, as long as anything bigger than 90 is quite extreme. Anything bigger than 10 is quite extreme. So as long as you get it up there, it shouldn't affect your answer too much. All right, there it is. So really not even 1% of all cars here. So 0.338% of cars get that good more than 40%. More than 40 miles per gallon. So again, the full answer is, according to the normal model, we expect 0.38% of all vehicles to get more than 40 miles per gallon. So if you're driving a car that's gets more than 40 miles per gallon, obviously we would have kilometers per liter. you'd have probably like an electric car or something that doesn't even use gas. Okay, let's see the next one here. All right, describe the fuel efficiency of the worst 20% of all cars. Okay, so now we have to work backwards. So now they're telling us, let me label this here. So there's 24. There's 24. And we're given a percentage, so we have to work backwards. And, you know, if this is 50% here on the left, you know, I'm guessing 20% is going to be somewhere around here. Okay, so I'm just going to, you know, assume that there is 20% of vehicles. So I need to get a Z-score. So how do I get a Z-score? Well, again, you can look at your tables, that pink sheet I gave to you, or we have our lovely calculator that will do this for us. So you go second function variables, and again, you got to go to inverse normal here, inverse norm. Hit that. The area is 20%. Oh, sorry, you got to do 0.2 because the total area is 1. Okay, that's really important. You'll get an error if you do more than 1. Okay, enter. And for those of you that are using the calculator, TI-83, you just punch this in your calculator, hit enter. Okay, so the Z-score, that's equivalent to, what just happened? Okay, the Z-score that's equivalent to 20% is negative 0.8416. 8416. Do 4 decimal places. This is so hard when the numbers are disappearing. It's like some magician's playing a trick on me. All right. Okay, now once we get a oh, what's the question asking again? Oh yeah, describe it. So now we have to get the corresponding fuel efficiency for that Z-score. In other words, we have to get our you know, we have to get our Y value here. So again, Z-score equals Y minus mu divided by standard deviation, and this time we have the Z-score, so 0.8416. I'm going to pause this video in a second and see if I can solve this problem here of the pen disappearing. Okay, so we're looking for Y here. Okay, so we're looking for our score there. So we have the mu, 24, and the standard deviation is 6. Okay, nothing there changed. So let me just do this. We have, oh, I should have kept that on the screen. That was silly. Oh, maybe I can pull it up. Second function entry, enter. Oh, there it is. Okay, times 6. There it is, plus 21. All right, 15.95. So our Y equals 15. Oh my goodness, I gotta get better. Sorry guys, it's the first time I'm using this tablet here, so I'm getting used to it here. So 15.95 miles. That should be an equal sign. Miles per gallon. Okay, so let's see what the question is again. So describe the fuel efficiency of the worst 20% of all cars. Again, you need a full sentence here. So according to the normal model, the worst 20% of all cars get less than 15.95 miles per gallon. Okay, I'm going to pause the video and hopefully I can figure some stuff out here, how to fix this pen. Okay, I don't think I was able to fix anything here, although I think my answer is wrong here, because this is supposed to be a 24, so we can just add another 3 here, so it should be 18.95. Anyway, let's just move on and deal with this. All right, a couple more questions here. Okay. Again, so we kind of did this one in class. What gas mileage represents the third quartile? So the third quartile corresponds to the 75%. So this is 24 mu. And I'm looking for the 75th percentile. So if this is 50%, and remember this, that at the first standard deviation, it was 84%. So this was 84%. 84% of the data fits in here. So I think 70% would roughly be somewhere to the left of that. So not 70, 75, which corresponds to the third quartile. Okay, so it's similar here. First step, I got to get a z-score for 75%, and I can only do that with a calculator or my table. So second function variables, inverse norm 0.75, I get 0.6745. So my z-score is is 0.6745. And now I need to calculate my y value, or what gas mileage. Remember, your y variable equals gas mileage. So let's calculate that. So I get z equals y. Oops. Y minus mu divided by the standard deviation. We have a z-score. I'm guessing there should be a decimal here that probably disappeared. Okay, so 0.6745. All right, equals y minus 24 divided by 6, I think our standard deviation was. Okay, let me just do this quickly. So I'll multiply that by 6 and add 24. All right, 28 miles per gallon. Y equals 28 28.005 miles per gallon. Okay, so the full answer here, according to our normal model, the 75th percentile or the third quartile is represented by 28.05 miles per gallon. Okay. Okay, I converted this thing to a PDF. I'm hoping this might be a little bit better for my pen recognition here. Okay, so let's keep going here. Next question is, describe the gas mileage of the most efficient 5 cars. Most efficient 5% of all cars. Let me read that again. Describe the gas mileage of the most efficient 5% of all cars. Okay, this is a little bit tricky question because the percent we're looking for is not 5%. It is actually 95th percentile, and that's because we are looking for the 5% that's the area that covers the best cars, and the best cars get the most miles out of here, most miles. So when our median is, my median is 24, okay, that means that this is 50% of cars get 24 miles per gallon, but the most efficient cars are way down here in terms of their Z-score. So describe the gas mileage. So again, let's do this very similar to the previous question, except they just wanted you to pick up on this little twist here. It's not 5% that you're looking for, it's 95th percentile. So again, let's get a Z-score for this. So the Z-score that corresponds to, oh, look at this, other problems now. Okay, no, I don't want that. Okay, Z-score, I'll ignore that little highlighted thing. Z-score for that corresponds to 95%. Second function, VARS, third choice, inverse normal, 0.95. I'm assuming I'm going to get a really high Z-score here, and actually 95%. Okay, we can probably do that one by hand because that'll fall onto right onto the, or actually should fall near the third standard deviation there. So it should be about, sorry, excuse me, should fall near the second standard deviation. So it's 1 point, so not quite there. So 1.6448. So 1.6448. Oh, this is much worse than the other one. Okay, I'll get through this question, then I'll try and figure a third option of doing these questions. All right. Okay, what a pain. I can't even do a dot there. There it is. Look at that. Perfect. Okay. Okay, so now I just do my calculation. I need to get my my value for the 95th percentile here. I need to get the gas mileage, and again, remember, gas mileage is your Y variable. Okay, so Z, oh, this is going to be a pain. This is not good at all. Z equals Y minus mu over standard deviation. And again, so now we got 1.66, 1. Okay. Let's just delete that. Look at that. Beautiful. Okay, 1.6448. Okay, alright, now if you're getting bored of this video and you kind of figure this out, maybe just skip through a little bit and get to some of the last few examples, because they are they're sort of the most, not the hardest, I should say, but they, they're trying to be a little bit tricky here. So, if you got the hang of this one, just skip on ahead here. So, but let me finish this anyway here. So Y, minus 24 over 6, and you get plus 24. All right, there it is. So 33.87 miles per gallon. Okay, so let me answer that in full here. So here's how we're going to do this. According to our normal model. Okay, that sentence is really important. Okay, you're saying that our data follows the normal model. Okay, and we can use this we can use this bell-shaped curve here. So according to the normal model, the 95th percentile, okay, cars are represented or are described by having a gas mileage of 33.87 miles per gallon. Okay, or in other words, we can say, according to our normal model, the top 5% of most efficient cars, okay, get over 33.87 miles per gallon. Okay, back to Word here. Hopefully this works again like it did at the beginning. Okay, what gas mileage would you consider unusual and why? Well, again, there's no right or wrong answer here, but you know, if we look at our model, okay, the middle here, the mean is 24. Oh, disappearing again. One standard deviation is 30, two standard deviation is 36, and then 42. Likewise over here we get 18, 12, and 6. So you can say, you know, if you consider two standard deviations, right, unusual, you can say that anything over 36 or under 12 would be unusual because that's two standard deviations away. Or if three standard deviation is unusual, you can say something like over more than 42 miles per gallon or less than 6 miles per gallon would be unusual. Okay, so again, there's no right or wrong answer. I would certainly, maybe if the point's in here or in here, I wouldn't really call it unusual. Okay, so anything outside the second standard deviation would be unusual. Okay. What percent of cars get under 20? Well, we did a similar question here, so I'm just going to do this fairly quickly here. So that's 24, and 20 would be right about here somewhere. Let me do a different pen here. 20. So again, what are we looking for? What percent? Again, percent is the area under the curve that describes that. So we need to get a z-score first, and to get a z-score, 20 minus the mean, so your score minus the mean over the standard deviation. And I think we did this one already. 20 minus 24 divided by 6. 4 divided by 6 should be, why do I keep doing that? 4 divided by 6 is 0.666, so negative 0.6666 here. Okay. Okay. I guess I can put a 7 there. Round it up. Let me get the area. Let me get the corresponding area. Second function, normal CDF. We're going to go from negative infinity all the way to negative 0.66667. Okay. 25% there. Okay, so that corresponds to what? 25.25%. So according to a normal model, we expect that 25.25% of all cars will get less than 20 miles per gallon. Okay, let's move on. Okay, an ecology group is lobbying. Lobbying means, maybe pushing for the national goal, calling for no more than 10% of all cars to be under 20 miles per gallon. If the standard deviation does not change, what average fuel efficiency must be attained? Okay, so what's happening here? First of all, what's the question asking us? The question is asking us what average must be attained. So now we're looking for a new mu here, a new mean, because this ecology group wants no more than 10% of all cars to be 20 miles per gallon. So essentially, we're looking at something like 10%. Well, 10% is going to be, over here, maybe even less than that. And they want this value to be 20 miles per, oh my God, 20 miles per gallon. Okay, and again, this is no longer 24, because if this was 24, that would be impossible. Okay, we just calculated it in the previous question, that 20 miles per gallon corresponded to 25%. Okay, 25% of the vehicles. Well, so this ecology group says that's too many cars. Okay, 25% is too many cars. That means there's lots of lots of big trucks on the road that are using up lots of gas. Okay, big gas guzzlers. So they want this to be 10%. Let me put a little arrow here. They want that to be 10%. Okay, so we need to find a new mu here. Okay, if we want to make change these values, the average has to be, the average car has to have a lot better fuel consumption than 20 than what was before. And I'll put in green here. I'll put a 24 was the old. Okay, we need to calculate the new mu. Okay, so this is no longer good enough. Okay, so let's do that. Okay, so we have z-score equals y minus mu divided by the standard deviation. Okay, so again, we're looking for this guy here. This didn't change. The standard deviation didn't change. Our y value is going to be 20. And we need to calculate the z-score. The z-score we can calculate from the 10%. So let's do that first. So second function. And again, you're going down to inverse norm because we're looking for a z-score now. So 0.1 corresponds to 10%. So the z-score is going to be negative. Let me get some black colors here. Come on, stay there. Okay, 1.2815. Okay, sorry guys about this pen thing. I'm gonna try and figure this out some other time here. Just trying to get through this through these few last examples. Okay, equals, and 20 is our y value minus mu over 6. All right. So take that answer, multiply it by 6, subtract 20. Okay, multiply by -1. And we get 27. Okay, 27.69. So 27.69. Stay there, please. Miles per gallon is our new average. Okay, so how are we going to answer this? So if standard deviation does not change, what is the average fuel efficiency? What average fuel efficiency must be? According to the normal model, the average fuel efficiency for our vehicles, for all the vehicles, has to be 27.69 miles per gallon if 20 miles per gallon corresponds to the 10th percentile. Or you can say something like this: according to the normal model, in order to meet the goal, the national goal, okay, the new mean has to be 27.69 miles per gallon. Okay, let's do not sure what happened there. Okay, all right, let's just ignore that. Okay, let me see how many more I have. Okay, two more. Okay, bear with me here. All right, these are the last kind of the important two here. Okay. Car manufacturers argued that they cannot raise the average that much because, you know, their cost would go way up if they try to make those type of cars. They believe they can only go to 26 miles per gallon. So what has to change? Well, the standard deviation has to change if everybody's to be happy here. What standard deviation would allow them to meet the only 10% under 20 miles per gallon goal? All right, so now we have our 26 miles per gallon. That's our mean. Okay, and we're looking for the standard deviation has to change. All right, so I'm actually going to use the information from the previous question because I've already calculated the z-score for 10%, and that was negative up there 1.2815. Try that again, 2815. Equals okay, so now we're looking for again, you know, so 20 is our score there. That corresponds to 10%. And the new average, okay, they say that 27, whatever that was up here, is too much. They can only go to 26. So what has to change? The standard deviation has to change. So let's calculate the new standard deviation. Okay. 20 minus 26. Okay, divided by negative 1.2815. Okay, the new standard deviation is 4.68 miles per gallon.